Hi students, welcome to class. So we've been talking about polynomials and different kinds of operations with polynomials and factoring polynomials. And so the next logical step is, of course, to divide polynomials. So before we actually dive into dividing polynomials, let's take a look at long division of numbers. You remember doing that, right? So let's say we wanted to divide 277 by 12. So back when we did long division, we would write it like this here, and we would look at, instead of looking at the entire, what's called the dividend, which is the 277, and the divisor, which is the 12, we would look to see how many times would the divisor go into the first part of the dividend. So we would only just look at this part right here, the 27, and we would see how many times does 12 go into 27. First we'd see how many times does 12 go into 2, and then if it didn't go into that first term, which of course it doesn't, then we'd move on and we'd look at the next digit. So how many times would 12 go into 27? And you can see in this case it goes in there 2 times, and so we then went ahead and took that 2 and we multiplied it by the 12, and that gave us the 24 right here, and then we went ahead and subtracted that from 27, and that left a remainder of 3, which we brought down, and then followed by the next digit, bringing that down, which was the 7, and then we would look at to see how many times did 12 go into 37, and of course 12 goes into 37 3 times, and so then we would take the 3 times that it would go in there and multiply 12 by that, and we got 36, which we would subtract. What remained was 1, and there was no more digits to bring down, and so we ended there, and we just said 1 was the remainder. And so as we got a little more sophisticated, we might have written the quotient as 23 and then 1/12, so that we would write the remainder as a factor of the divisor, and we'd say that 277 divided by 12 was 23 and 1/12. And this was the form that we were writing it in. We were writing it as the dividend. When we divided the dividend by the divisor, we would write it as the quotient plus the remainder over the divisor. And of course, if we wanted to check our answer, we could take the 12 and we could multiply it by the 23 and 1/12, and we would see that we would get back to this 277. Well, we can use this same method to divide polynomials. In the following lesson, we will be looking at a different way, which is called synthetic division, but in this lesson, we're going to be looking at using this long division process to divide polynomials. So here's an example. I would like to divide 4x cubed plus 2x squared plus 3x plus 5 by x squared plus 3x plus 1. And so I went ahead and set up a format really similar to this long division of numbers, but now we're doing long division of polynomials. And you can see that I have the divisor out in front, which is the x squared plus 3x plus 1, and I have the dividend underneath the division sign. So how does this work when I'm dividing polynomials? Well, when you're dividing polynomials like this, first thing you want to do is make sure that you have your polynomials always in standard form, which I do in this case. They're in highest to lowest power. I also want to make sure that there's no missing terms in the dividend. So if there was, like, say for instance, let's say there was no x squared term, I'd want to replace that spot in the polynomial with a 0x squared or whatever term's missing. I want to put basically what's called a placeholder in. We don't have that situation here. Hopefully we'll see one arise where we can see how we handle that. But anyway, then the next step is to, we take and we divide the first part of the divisor by the first part, or I'm sorry, the first part of the dividend by the first part of the divisor. So basically what I'm going to do is see how many times I can divide x squared into 4x cubed. And so I know I can see that if I were to divide 4x cubed by x squared, it would go in there 4x times, because 4x times x squared is 4x cubed. So just like I did with numeric long division, I'm going to take that 4x and I'm going to multiply that by the divisor, and I'm going to subtract that from the polynomial above. So let's see what I get when I take 4x and I multiply it by this whole divisor, this x squared plus 3x plus 1. I get 4x cubed plus 12x squared plus 4x. Now remember, I'm subtracting that, so basically what I want to do is I want to add the opposite of each one of those. So I could change this to addition, change every one of these to the opposite sign, and then I'm going to go ahead and add and see what's remaining. So when I add, I can add my 4x cubed and the negative 4x cubed, and of course they're going to cancel out. They should always cancel out. I'm going to add the 2x squared and the negative 12x squared, and that's a negative 10x squared. I'm going to add the 3x and the negative 4x, and that makes negative x. And then I'm going to bring down the next term, which is the plus 5. And now I'm going to see how many times does this divisor go into this polynomial, into negative 10x squared minus x plus 5. So I'm going to start the whole process over again, but again I'm going to multiply this time the first thing in the polynomial divisor and the first thing down here, which is the negative 10x squared. And I can see that that goes in there negative 10 times. So now I'm going to take that negative 10 and I'm going to multiply it by the x squared plus 3x plus 1, and then I'm going to subtract that from the remaining polynomial. So that gives me a negative 10, remember I'm subtracting it, x squared minus 30x, and then minus 10. And then I'm going to go ahead and change this to addition of the opposite. So that means each of these is going to change signs. And so when I add, of course, those first terms, the negative 10x squared and the positive 10x squared, are going to cancel. That should always happen. Then when I add the next two terms, I get a positive 29x and a plus 15. Now then I go back and I see, okay, well let's see if I can keep going and dividing further, and I'm going to see, can I divide the x squared into the 29x? And of course I cannot, because the power is too high on the x squared to divide into a 29x. And so that actually is our remainder. Now how do we write that? Well, we can write that as a fraction of the original divisor, which would look like this. Now another way to write that is to write it as a product of the original divisor and the quotient plus the remainder. So that would look like this. That would be x squared plus 3x plus 1 times the quotient, which is 4x minus 10, and then plus the remainder, which is 29x plus 15. And then if you were to expand that all out, you would get it to equal the original polynomial. So let's go ahead and take a look at one more example, and then we'll end with a few you try questions. So this time I want to divide 6x to the fourth plus 5x cubed plus 2x plus 8 by x squared plus 2x minus 5. So you can see that they've already set this up in the long division form, and you can see that they went ahead and added a placeholder in the dividend where there was a missing term. There was not an x squared term, and so then to make up for that fact, they went ahead and put a 0x squared in that place. And that's going to be really important to make sure that you do this anytime you're doing long division. So as we did before, we're going to start off dividing the first term of the divisor into the first term of the dividend. And so I can see that if I divide x squared into 6x to the fourth, I'm going to get 6x squared. So now, as I did before, I'm going to take that 6x squared and I'm going to divide it by everything in this divisor, and I'm going to subtract it from the original polynomial. So right down here, I'm going to just write what I get when I get that product. So when I take 6x squared and multiply it by x squared, of course I get 6x to the fourth. And when I multiply 6x squared by positive 2x, I get positive 12x cubed. And then when I multiply 6x squared by minus 5, I get negative 30x squared. And this is exactly why I needed to make sure I put a placeholder in there, because now I have this x squared term, negative 30x squared, and I have to have something to combine with it from the original. So remember, I'm subtracting here, so I want to go ahead and change that to addition of the opposite so that I can just plan on adding instead. And I'll change the sign on everything. And so now when I combine my like terms, the first terms, of course, are going to cancel. They're opposites of each other. The x cubed terms, that's going to leave me with negative 7x cubed. And then finally, I'm going to get a positive 30x squared. Then I'm going to bring down the next term, which is a plus 8. And I'm going to start the process all over again. I'm going to take the first term of the divisor and divide it into the first term of the dividend. Okay, so oops, that was supposed to be the 2x that got brought down. That was the next term. My fault. And so now we're going to start that process all over again, and we're going to say, okay, so now I've got to take the x squared, the x squared, and we're going to divide it into the negative 7x cubed. And when we divide that in there, it can go in there negative 7x times. So I'm going to take that negative 7x and I'm going to multiply it by that divisor, which would give me negative 7x cubed minus 14x squared plus 35x. And again, I'm going to change that to addition of the opposite, change that to add, every sign changes. And I'm going to combine my like terms, and of course the first terms are going to cancel. The next terms add up to 44x squared. The next terms to a negative 33x. And then of course we're going to bring down that last term, that plus 8. So that's coming down now, right there. And I can see how many times does x squared go into 44x squared. So I'm going to go ahead and see how many times does this go into 44x squared, and it'll go in there positive 44 times. Now I'm going to take that positive 44, I'm going to multiply it by the divisor, and we're going to subtract again. So 44 times x squared is 44x squared. 44 times positive 2x is 88x, and positive 44 times negative 5 is negative 220. Change to addition of the opposite, and I'm going to combine all my like terms. And when I put all my like terms together, of course the first terms are going to cancel. The next terms add up to a negative 121x plus 228. And of course there's no further I can go, because I know clearly that I can't divide x squared into negative 21x, because it's a lower degree on the x than it is on the x squared. And so I'm actually ready to write my answer. So my answer is going to be the product of the original polynomial, or of the the divisor, I guess it is, and that would be the x squared plus 2x minus 5, and then times my quotient, which is 6x squared. I'm going to run out of space here. I think I'll write it up above the problem. So again, the original divisor times the quotient, which is 6x squared minus 7x plus 44, and then plus the remainder, which is the negative 121x plus 228. So if we were to go ahead and multiply this back out, multiply these two polynomials, and then add the remainder, we would get the original polynomial. So that is a way to check it. It's not an easy way to check it, but it certainly is a way that would check. And so this is my final answer in this form, which is the quotient equals the, plus the remainder equals the dividend. So we're going to end the lesson with a you-try problem. So I'm going to have you give this problem a try, and I'll help you kind of get it set up first, and then you can pause the video, give it a shot, and tune back in to see how you did. We'll leave your turn example number 4 to do in class together. So if we're going to go ahead and set this up, the first thing we want to do is identify what is the divisor, and of course the 3x squared plus 6x plus 1 is the divisor. So we're going to go ahead and write that out in front. 3x, oops, I don't know what I'm writing. 3x squared plus 6x plus 1, and then our dividend, notice, is missing a term right there. It's missing an x squared term. So as we write this, we're going to put a placeholder in there. So this would be a 15 x cubed plus 0x squared plus 8x minus 12. So there's your setup. So if you need to go back and take a look at the examples as you're working, feel free to do that. Give that a try, and once you've given that a try, tune back in and you can check your answers. So go ahead and pause the video now. All right, thanks for giving that a try. Here is the answer. You can see that the quotient was 5x minus 10. The remainder was 63x minus 2. And then to write it in that form that we talked about, it would look like this. So be sure to jot down any questions that you might have, and when we see each other in class, you can bring them up. We'll see if we can clarify them, and we'll also try another one in the your turn question number 4. And hopefully by going through that one and answering any of your questions, you can perfect the art of long division of polynomials. Thanks for coming to class.